Hey there!
Ever wondered how your computer talks to the internet? Or how your messages magically arrive at the right place? It all boils down to one thing: protocols. These are the rulebooks that define how devices communicate, how data is packaged, sent, received, and even how it should be interpreted. Think of them as traffic laws for the digital highway, ensuring everything flows smoothly without chaos. Before moving to the explanation of protocols, make sure you have watched our video on the OSI model. Now here's something cool. These protocols don't work randomly. They're organized into layers in a framework called the OSI model. This model has 7 layers, each responsible for a specific part of data transmission, and each layer has its own set of protocols doing the heavy lifting. Let's break it down from the top layer all the way to the physical connection. Starting at the application layer, this is where users interact directly with network services. Here you'll find protocols like HTTP, HTTPS, which let you access websites, and FTP, which helps you transfer files across systems. Ever downloaded a file or opened a web page? Yep, these are your go-to protocols. Also, SMTP, IMAP, and POP3 live here, making sure your emails get sent and delivered. Next is the presentation layer. Think of this as the translator. It formats and encrypts data so different systems can understand each other. Protocols like SSL, TLS are used here to encrypt data. You know, that little lock icon in your browser. That's TLS keeping your info safe. Another example is MIME, which formats emails to support text, images, and attachments. Moving down to the session layer, this one manages and maintains connections between devices. It's like a host at a party, making sure conversations happen smoothly. NetBIOS is used here for local network communication, and RPC, Remote Procedure Call, helps different software components talk to each other across a network. Then we have the transport layer, which ensures data is delivered error-free, in sequence, and without losses. This is where TCP and UDP come in. TCP is like a certified mail service, it guarantees delivery. UDP, on the other hand, is the express courier that skips the checks for speed, making it perfect for gaming and live streams. Now let's hit the network layer. This one handles routing, figuring out the best path for your data to travel. IP, Internet Protocol, is the star here, assigning addresses and moving packets across networks. We also have ICMP, which tools like ping and traceroute use to diagnose network issues. Heading into the data link layer, this layer deals with physical addressing and error detection. Think of it as the mailroom, ensuring each package has the right label before it's sent off. Ethernet is the most common protocol here for wired networks, and PPP, point-to-point protocol, is often used for direct connections like dial-up. Finally, the physical layer. This is where the rubber meets the road. It's all about the actual hardware and transmission of bits over cables or radio waves. Protocols aren't as defined here, but technologies like Wi-Fi, IEEE 802.11, and Ethernet standards like 100 base T govern how bits are transmitted physically. Each layer plays a vital role, and the protocols within them work together like an elite team, making sure your data travels from point A to point B safely, efficiently, and accurately. So next time you stream a video or send a message, remember, there's a whole layered world working behind the scenes. Give us a like and hit subscribe for more cybersecurity tips. Catch you next time.